now discuss the characteristics of a sound wave. Sound wave can be described by 5 characteristics: wavelength, amplitude, time period, frequency, and velocity. Let us first discuss the first characteristic, that is wavelength. The distance between two consecutive compressions or two consecutive rarefactions is called a wavelength. The wavelength is represented by the Greek alphabet lambda and its SI unit is meter. In the given figure, we have a wave. This is the peak or crest and this is the trough or well. One wave comprises of one crest and one trough. The distance between two consecutive crests is defined as the wavelength. So the distance between this crest and the nearby crest is the wavelength of the wave. The next characteristic is the amplitude. The magnitude of the maximum disturbance in the medium on either side of the mean value is called the amplitude of the wave. It is denoted by the letter A and its SI unit is meter. But for sound, the amplitude is expressed in kilogram per meter cube. In the given figure, we have a single wave represented by a crest and a trough. Here, the amplitude means the maximum displacement from the mean position to the top. This distance is the amplitude, and for the trough, it is the distance from mean position to the minimum position here. So this distance is amplitude and it is represented in meter. The first figure represents a wave of high amplitude because the amplitude is higher here, in the sense the distance from the mean position to the maximum, the top position, is more than the second figure. So this first figure, the wave represents a high amplitude, and the second figure, the wave represents a low amplitude wave. The next characteristic of a wave is its time period. Time taken to complete one vibration is called the time period. It is also defined as the time taken by two consecutive compressions or rarefaction to cross a fixed point. It is denoted by capital T. As it is time, its SI unit is second. In the given figure, first figure, we can see the wave. The time taken for two consecutive crests or the formation of one wave is known as the time period. But here, because we can easily represent the time between two consecutive crests, it is marked as capital T. And here in the next figure, we have the distance between the two nearby crests represented as one wavelength. The distance travelled by one wave is the wavelength, and the time taken for one wave is the time period. Another very important characteristic of a wave is its frequency. The number of vibrations in 1 second is called frequency of the wave. It is denoted by nu and its SI unit is hertz. The frequency of a wave is the reciprocal of its time period, that is nu is equal to 1 by T. In the given figure, we can see number of waves produced in a particular time. The first figure, we have 2 complete waves, and in the second figure we have 3 complete waves, and in the last figure we have many waves. The number of waves produced in 1 second is the frequency. Because in first figure the waves are less, it is of low frequency, and the third figure there are so many waves in a particular time, so it is a wave representing high frequency, and the second figure will be of medium frequency. The next characteristic of the wave is its velocity. The distance travelled by the wave in 1 second is called velocity of a wave. As it is velocity, the SI unit of velocity will be meter per second. In the given figure, the wave is, we can see a wave propagating. The distance travelled by the wave in 1 second is called its velocity. Now we can have a relation between three very important characteristics of a wave, that is velocity, frequency and wavelength. We know that velocity is distance travelled by time. Therefore, wave velocity will be equal to distance travelled by time taken. So, wave velocity we represent by v, and distance travelled will be equal to the wavelength. Let us take a fixed distance, that is wavelength, and we know that one wavelength will be travelled in a time known as time period. So distance travelled is equal to wavelength, and time taken for this wavelength will be its time period. So we have v is equal to wavelength represented by lambda, time period represented by t. But in this equation we have 1 by t is equal to nu, that is nu, the frequency, is the reciprocal of time period. When we substitute this relation in the first equation, we have v is equal to lambda, instead of 1 by t, nu. So v is equal to nu lambda. So the relation between velocity, frequency and wavelength is v is equal to nu into lambda, or velocity is the product of frequency and